Polarization of atoms and molecules. A hydrogen atom is electrically neutrality in a common time scale. But in a very short instant, for example, about the period of an electron revolving around the nucleus, the hydrogen atom appears to be polarized. A polarized atom must be affected by an electromagnetic field. The hydrogen atom is the simplest atom. It is believed that many kinds of atoms are similarly polarized in a very short time interval. A small molecule is not always oscillating, deviating from the mode of electromagnetic equilibration. Hence, in a very short time interval, a molecule may be affected by an electromagnetic field. Based on this reasoning, it may be said that many kinds of atoms and molecules should be affected by electromagnetic fields. The electromagnetic field of a photon. Light has been considered from two different viewpoints, the wave theory and the particle theory. To explain the photoelectron effect, Einstein suggested that light energy propagates in packets, that is, photons. This is the particle viewpoint of light. The energy of a photon is E equals h nu. Contrarily, from the viewpoint of wave theory, light is looked upon as a propagating series of electromagnetic wave. The two different viewpoints describe the same objective thing, but they express different features of light. For the purpose of understanding the energy transfer process from photons to material particles, both viewpoints need to be combined. What is a photon? Einstein and Planck defined a photon by the frequency of the light. They were talking about the effects of energy emission and absorption. For the special case under discussion here, a photon is looked upon as a section of the electromagnetic field of the traveling light. The length of the section is the wavelength of the light. In the corresponding period, the electromagnetic field completes an oscillation. A thread of traveling light can be imaged as a series of photons, and a photon is a section of moving electromagnetic field. Consider the case of a photon interacting with a hydrogen atom. Since the average size of a photon of visible light is more than 2,000 times larger than a hydrogen atom, as mentioned above, the situation of a photon interacting with a hydrogen atom can be viewed as the hydrogen atom penetrating the photon. The photon is viewed as a stable electromagnetic field, and the hydrogen atom is moving through the electromagnetic field of the photon.